Welcome to this video on subtraction in different base systems of numbers. So if you're watching this video, I'm going to assume that you've already watched our videos on different number systems such as octal numbers, binary numbers, hexadecimal numbers, and also our previous video where we talked about addition in these different base systems. But in this video, we're talking about subtraction, how we subtract numbers. And before we start talking about these different base systems, octal and hexadecimal and so forth, we're going to start with a simple example of subtraction using just ordinary decimal numbers. Now, I'm sure that you're all capable of subtracting 243 minus 62, but what we're going to do is we're going to look at the method in a little bit more closer detail, because the method itself is going to become important when we start to look at the different number systems that follow. So when we subtract these two numbers, we start with the right-hand column and our result appears below. So to begin with, nice and easy, 3 minus 2 gives us 1. The next column is 4 minus 6. Now, what we're not allowed to do is to say, well, 4 minus 6 gives us minus 2. We're not allowed to start using negative numbers in our result quite yet. And so even if you learnt this sort of style of subtraction in school, you might remember you have to borrow 1 from the next column. And so let's do that in our example here. We borrow 1, and so 2 becomes 1. And we add a 1 in front of our number at the top like so. So 4 has become 14. And then we can say 14 minus 6 gives us 8. And so 8 becomes our next result. And remember, we borrowed 1, so we've only got 1 left in that last column. So it's essentially 1 minus 0. There's nothing else there. And so we have 1 there. So 243 minus 62 gives us 181. Now, the reason I wanted to bring up this example, which I'm sure you're all happy with, but this whole act of borrowing the 1 here and adding the 1 to our term in the next column, it relies on our numbers being to the base of 10. So our decimal system of numbers is to the base of 10. So what we've really done is, rather than borrowing 1 and putting a 1 in front of the number here, yes, that does work in the base of 10, but what we're really doing, if we think about it, is we're stealing a base from the next column, and our base is 10, so we're adding 10 to our number by borrowing from that next column. And that only applies because our numbers are to the base of 10. So in our next examples, when we look at octal numbers and such like, the base won't be 10. We'll have different base numbers and we'll be borrowing different amounts from those columns. So let's have a look next at how we would subtract octal numbers from one another. So here we have another example now where we're going to subtract two octal numbers. We're going to say 342 minus 66. Now it's tempting to read those as 342 minus 66, but remember, these aren't decimal numbers, these are octal numbers. You can go back and watch our octal video, which goes into more detail about octal numbers if you haven't already. So let's look again, starting at the right hand column. We're going to be doing 2 minus 6. So straight away we run into a problem and we have to borrow from our next column to avoid getting into the territory of minus numbers. And so what we're going to do is we're going to borrow 1 from our column to the left. And so 4 is going to become 3. Now remember, our octal numbers are to the base of 8. And so in our previous decimal example, when we borrowed 1, we were adding 10 because we were in the base of 10. Octal numbers are to the base of 8. And so really when we borrow 1 from the next column, what we're doing is, and I'll mark this on, we're adding 8 to the column on the right. So now, rather than 2 minus 6 that we had originally, we've now got 8 plus 2 minus 6. So that's 10 minus 6, which gives us a result of 4. So now looking at the next column, we can see that we've already borrowed 1, so we're left with 3 minus 6. So again, we have a problem where we have to borrow from the next column. So the 3 in our column to the left would become 2, and we're adding 8 to the column to the right. So 3 becomes 8 plus 3, which is 11. 11 minus 6 gives us 5. Finally, on the left-hand side now, well, we've got 2 by itself. There's nothing else here, so 2 or 2 minus 0 is just 2. And so we can complete our subtraction like so. Let's have a look at a binary example. We have 1010 minus 101. And remember, the binary system of numbers is to the base of 2. Again, we've got a video on binary numbers if you want to go back and have a look at that. But in this case, we're going to perform exactly the same method as before. Starting at the right-hand side, we have 0 minus 1. So straight away, we're going to have to borrow from the next column. And so 1 in that column becomes 0. But remembering we're borrowing a base, we're borrowing one lot of the base, as it were. And so what we're doing really is we're adding 2. We've got the base of 2. So we're adding 2 to the right-hand side column. So now we have 2 plus 0, or 2, minus 1. And 2 minus 1 gives us 1. In the next column now, we've borrowed the 1s. We've got 0 minus 0. Well, 0 minus 0 gives us 0. And in the third column, again, we have this problem of 0 minus 1. And so we have to borrow again from the next column. And so 1 becomes 0. We've borrowed the 1, but it's a base of 2. So we're adding 2 to our next column. And again, 2 minus 1 is going to give us 1. And so we find our result there. 1010 minus 101 gives us 101. The very last example for this video is subtracting two hexadecimal numbers. And remember from our previous videos as well that hexadecimal numbers are to the base of 16. And so we have our possible digits of 0 through to F, which correspond to 0 through to 15. If you're not sure about where those digits come from or what they mean, it's worth going back to our hexadecimal video where we explain that in a bit more detail. But I'm assuming you've watched that or you're familiar with hexadecimal numbers, and we're going to perform this subtraction here using exactly the same methods as we've done for the previous. We're starting on the right hand side. C minus D. So first of all, remembering that C corresponds with 12 as a decimal number and D corresponds with 13. And so what we can do, in fact, I'll make a little note on the side here. So we're doing C minus D, and so that corresponds with 12 minus 13. Well, again, 12 minus 13 would give us a negative number, so we're going to borrow from the next column to the left here. So 3 to the left is going to become 2. And that means that because we've borrowed 1 or one lot of the base, we are adding 16 to our term on the right hand side. So going back to our little notation over here down the side, we can say that we've added 16, or in below we've added 16. So now we have 16 plus 12 minus 13. And if we do 16 plus 12, we have 28. So we have 28 minus 13. which leaves us with 15. And 15, remember, is a permissible digit in our hexadecimal number system. We're allowed 0 through to 15, and 15 actually corresponds with F. And so here we're saying 28 minus 13 gives us F as a hexadecimal result there. So we'll put that in below. Okay, so finally, what remains in our left-hand column is nice and easy. We're left with 2 minus 1, and 2 minus 1 gives us 1. And so our result there of 3C minus 1D gives us 1F as a hexadecimal number. So these have been some simple examples, but I hope you found them useful in learning how we can perform subtraction in both octal, binary, as well as hexadecimal number systems.